Hi, my name's Kayla Sweeney, and I'm doing the physics of a GPS system, which is a real world application. The history of the GPS began when it first started developing during the Cold War for shift radio signals. These were known as the Doppler effect. Even though these were not our typical GPS systems today, they were still super important during this time for different radio signals. The GPS stands for Global Positioning System. It works by sending satellites up into space to send signals to Earth. This became the inspiration for this type of system. In the 1970s, the United States wanted to create a satellite navigation system for the military, so they created a system known as Navstar GPS. How does it work? There are many satellites in space that roam about the Earth. There are about 33 to 34 as of right now. Signals are sent out to the receivers, such as cell phones, from multiple satellites around the area of the Earth. Receivers can be anything, such as a computer, a phone, a tablet, anything that can receive a signal from the satellites. These signals allow the distance to be calculated and can be very precise. There are three important contributors to the GPS: the satellites in space, the ground stations, and the receivers, such as your cell phone. Even though we call our cell phones GPSs, the whole system is a GPS, and the phone is only a receiver.
These days. GPS receivers guide airplanes, cars, and even cell phones. But did you know that the Global Positioning System is basically a big clock in space? There are 30 GPS satellites in orbit, and they just broadcast where they are and what time it is. All your phone GPS has to do is receive signals from four satellites, and it can triangulate its location in the four dimensions in which we live: three space and one time. But actually, it's not that simple. In order for navigation to work, the satellites carry atomic clocks accurate to the nanosecond. Otherwise, your GPS receiver might tell you you're halfway across town when you're still in the driveway. And special relativity tells us that moving clocks run slow, while general relativity tells us that clocks run faster higher in a gravitational field. These effects don't quite cancel. General relativity wins out, and time indeed runs faster up in orbit with the satellites. But some of the engineers working on the first GPS satellite couldn't bring themselves to believe that their clock would actually run fast just from being higher up, so they sent it up uncorrected. Within minutes, it was off by enough to impair GPS navigation, and by the end of the day, GPS receivers would have been wrong by tens of kilometers. Needless to say, the engineers turned the correction back on, and these days, they trust general relativity. Oh, and one last thing: GPS is also a nuclear weapons detector. There are always at least four GPS satellites visible from any point on Earth, and because of this, any nuclear detonation will be seen by enough satellites to pinpoint exactly where and when it took place.
So, the physics behind a GPS. GPS signaling is used with a method called trilateration. It is able to do this by finding a position of the receiver on Earth using the difference of four satellites that you see here in this picture. The relationship between the speed of the signal and the amount it takes for the signal to travel will equal the distance traveled. This is why the signals are so precise, and without general relativity, it would not be possible to have the most accurate reading like we do today. So the equation would be distance traveled in meters equals the speed in milliseconds to the negative 1 times time in seconds. Some fun facts about GPSs. GPSs were originally invented for military use only. It wasn't until 1983 when Ronald Reagan made the GPS available for commercial use to the public. GPSs are used for tracking so many different things. You can use it to get anywhere you need to go, or you can even use it to track different animals such as sharks. This is an app that you can download where you can track multiple different sharks, and every time a satellite pings them in a different place. So it will save this, see the time and date that they're around certain areas of the ocean and the date that they were there. Thank you.